Everybody, my name is Afolabi, and today I'll be taking you through mathematics. Remember, we have done so many videos on mathematics. You can still follow it up on our page. Today we'll be looking at coordinate geometry, which is a branch of mathematics that deals with what? That deals with coordinate system. And when we say coordinate system, we are talking about the x and y axis. So the general idea of coordinates, coordinates revolves around what? Revolves around x and what? Y axis. X and y axis. Okay? My x axis is also known as is something I also call the ordinates. Could be called the ordinates. Why the y axis is the abscissa. Okay? So if you have a point to describe in your x and y axis, for example, you have to describe you have to locate point minus 2, minus 2, 3 on your x and y axis. This is the x axis, this is the y axis. Okay? Don't forget this is a sketch, this is not a plot, so I could just locate the point. Now what this represents when you see a point, this way, this is a point. When you see a point, what this represents is this is your x and this is your y. So that means on the x axis, we have to locate point x as what? As minus 2. Of course, this is the negative side of the x. Okay, so my minus 2 will be somewhere around here, and this is y as it's positive. The positive y will be up here, so this is 0.3. So when you trace the 0.2 and the 0.3 together, that point will be your point P, which is what? Point P, which is minus 2, 3. So what this is trying to tell us is that anytime you see a point, and that point is written as x, y, what it simply means is that on the x-axis, if you trace that point to the x-axis, you have what you have here. If you take that point to the y-axis, you have what you have here. Of course, if you have another point Q, which is 5, 1. 5, what does that mean? That means that on the x-axis, you have 5. Let's say we have 5 on the x-axis, and on the y-axis, you have 1. So you trace the x-axis and the y-axis. This will be your point Q, which is 5, 1. So anytime you see me write something, something, that simply means that on the x-axis, I have 5. On the y-axis, I have 1. Okay? This is the origin. The origin too can be used to describe. You could have point R, which is 0, 2. That simply means on the x-axis, I have what? 0, and on the y-axis, I have 2. So this will be my point what? Point R. Point R on the x-axis, I have 0, okay, and on the y-axis, I have 2. So the general idea of coordinate systems come from the interaction of points like this with another. Okay, a basic usage of the coordinate system is the distance between 2 points. Okay, so calculate distance between 2 points. Distance between 2 points. If you have 2 points on the x and y coordinate system, you have point P, which is x1, y1. You have point Q, which is x2, y2. You can use the coordinate system to find the distance d between the 2 points. Okay, you can find the distance d between the 2 points. It's allowed. The distance d can be proved. Okay, the distance d is what? Square root of x2 minus x1 all squared plus y2 minus y1 all squared. That's the distance between the 2 points. Look at this question. Find the distance between points minus 1, 4 and 3, minus 2. Now find the distance between these 2 points. Okay? Now you can take any of the points as your x1 and y1. You can take any point as your x2 and y2. For the sake of convenience, I'm taking this one as the first point, x1, y1, and I'll take this point as the second point, s2, y2. Correlate with what I have here. So if I'm to calculate the distance between them, I'll simply go this way. I'll use this formula which I have here. The distance d is square root of what? Square root of x2 minus x1 all squared plus y2 minus y1 all squared. So what do I have? I have d to be square root of what? What's x2 minus x1? This minus this, that's 3 minus 1 all squared. 3 minus 1 all squared plus what? Plus minus 2 minus 4 all squared. So what do I have? I have what here? Here I have 16. And here I have 36. So here I have square root of 52 units. So the distance between the 2 points, minus 1 and 4, and 3 and minus 2 will simply be by putting in these values into where I have x2 and x1, y2 and y1. You can see x2, x1, 3 minus 1, minus 2, minus 4. That's here. All squared. This one will give me 36. This one will give me 16. Added both of them together, I have 52 square units. That's not all. We can also use it to find find, please continue. To find the distance, the midpoint between 2 points, you have a point A, which is x1, y1. You have a point B, which is x2, y2. You can find the midpoint between the 2 points, the midpoint, okay? Let's say C is the midpoint, which is xm, ym. This can be proved that C, the coordinates of C, which is ym, ym, will be the midpoint between these 2 points will be what? Will be x2 plus x1 over 2, y2 plus y1 over 2. This can be proved. Okay? So if you have a question like this, find the midpoint. Find the midpoint between 2, minus 3 and 0, 5. I'll find the midpoint. All I need to do, remember, just like I told you in this case, you can use anyone for your x1 and y1. So I could use this for x1, y1. I could use this for s2, y2. Okay? So going forward, I'll just say my midpoint, C, will be what? x2 plus x1 over 2, y2 plus y1 over 2. So what do I have? I have C to be what? x2 plus x1, that's 0 plus 2 over 2. And this I have what? Minus 3 plus 5 over 2. So what do I have here? C is what? This will be 1, 1, 1. So the midpoint between these 2 points will simply be 1, 1. Now the most important parameter in describing a line is the slope or the gradient of the line. In fact, it is more important than the distance between 2 points or the midpoint. The slope of a line, which is also known as the gradient, tells us the general characteristics of the line, the relationship between your x value and your y value. If one is increasing as the other is increasing, or one is increasing while the other is decreasing. Of course, we can have 2 values for slope. Generally, our slope between two points or gradient is represented as m, and it is y2 minus y1 over x2 minus x1 in between 2 lines. Now, your slope can either be a positive slope. It could be positive slope where you have maybe a point here, you have another point here, you have point x1, y1, you have x2, y2. This is a positive slope. It's increasing. The value of x is increasing, the value of y is increasing. You could have a negative slope. A negative slope where the value of one is increasing and the value of the other is decreasing. Here you have x1, y1, and you have x2, y2. You can see that in this case, x and y are both increasing, but in this case, x is decreasing, x is increasing or decreasing, while y is increasing on both sides. So here we have a negatively sloped graph where we have minus m, and here we have a positively sloped graph. Now, the slope of a graph is very, very, very important. For example, you can be told find the slope of the line joining points minus 4,0 and 2, minus 3. Now find the slope of the line joining that. Okay, remember you can always use anyone as your x1, y1 conveniently. You can decide to use this as x1, y1 and use this one as well, x2, y2. Or it could be the other way around, so you don't need to disturb yourself about the mistake. So the slope m will be what? y2 minus y1 over x2 minus x1. And what would that give you? y2 minus y1, I have a minus 3, y2 minus y1, come on, y2 minus y1, that's 0, minus 3, y2 minus y1, okay? Divided by x2 minus x1, I have a x2 minus x1, minus 4, minus 2. So what do I have up here? Up here I have 3, down here I have a minus 6. So that means the slope m is what? Minus half. Do you see that this graph is a negatively sloped graph? It's just like this type of graph in which the value of one is decreasing while the other is increasing. Now, the characteristic of having a slope or gradient for a line is to be able to predict or find out what the general equation of the line would be. Anytime you have a line, any straight line whatsoever, can always be written as y equal to mx plus c. This is the general equation of all lines. All lines can be in this form, where m here will be the slope, and c here will be the y-intercept. What do I mean by y-intercept? Where the graph cuts the y-axis, which is here. So anytime you are given an equation of a line, you might be told to find the slope of the line and the y-intercept. All you need to do is to make sure that you reframe the equation into this form. Then the coefficient of x will be the slope, y, whatever you are standing here, will be the intercept. For example, we said find the slope slope and y-intercept. Find the slope and y-intercept for 2y equal to 3x plus 7. Look at this. I have 2y equal to 3x plus 7. I want to find the slope and the y-intercept. But you can see this is 2y, this is y. This is 3x, this is mx, and this is 7, this is c. I won't just pick this as my slope or this as my intercept. I will need to make this coefficient of y to be 1 so that it conforms with the general. So I'll just divide by 2. If I divide through by 2, I have y equal to 3 over 2x plus 7 over 2. I divided by 2. So that means what I now have here will be the slope, and what I have here will be the y-intercept. So my slope for this line is 3 over 2, while my y-intercept is 7 over 2. So anytime you are given the equation of a line, it is very, very easy for you to identify the slope and the y-intercept. All you need to do is to write the equation of the line as y sub j formula. You pick the coefficient of x to be the slope, and whatever you have here to be the y-intercept. So the other things that have to do with coordinate geometry will be continued in the next video. Thank you.